Episode 3, Getting Loopy. In this episode, we're going to look at what value programming can bring in the sense of rapid repetition of tasks, or quickly reading and checking multiple files, or what we call an array in programming. At the end of last episode, we started the box test on a development, where we looked at drawing a box in processing. We also looked at drawing a second box on top of that using different coordinates. In processing, we know that void draw is a repeating piece of code, a repeating function. We can use a looping command within a function where we need to iterate results rapidly or check the validity of a value through an array or a massive amount of numbers. There are three main types of loop within processing, and within most programming languages there are. They are an if, a for, and a while loop. If loops through a section of code while a statement is true. For loops through a list section for a predetermined amount of times. And while loops through a section while a statement is valid. The three looping methods are also listed in almost the priority that you'll use them. While loops are used very rarely in current programming, unless required, as due to their requirement of a true or valid statement, they can cause locking loops that are neither exitable or changeable. This means that the statement that it's looking for may never be true, and the program will freeze and loop through that statement forever. For loops are really good for reading or accessing values within a predetermined set of information. For example, checking if a value exists in an array. For the record, an array is an indexed set of elements. This can be numbers, text files, names, anything. All of these can be elements in an array should we want them to be. We'll come back to arrays at a later stage. While the other two loop for a predetermined amount of times based on a value or a statement being true, an if loop acts as more of a redirection to the flow of code versus a complete stop and start loop. The easiest way to visualize these is through flow diagram. These diagrams here show really crude versions of each of the loops. Starting with if, we can see that it's the shortest and simplest of the three, simply because it acts as a diversion, going down, and whether a value or statement is true or not depends on whether the code is accessed. There is no way for the program to freeze up indefinitely here as long as the input statement exists. For loops are a more advanced version of this, whereas you can see there is an actual recursive loop. For loops have an initial statement that limits their existence. For example, loop while a value is less than 10. When we define for loops, we internally define that so that there's no way for these to be locked down and close the system. It simply checks that the value is still relevant, that the for loop is still relevant, accesses the code, and checks whether the for constant is true. If it is, it loops around. If it's not, we continue with the rest of the program. While loops have an extra step that make them a bit more dangerous. While loops exist on the truth or false of a statement, whether that be a value equaling something or an actual true or false boolean. If the statement is true, the while code exists, but if you do not make the statement false during the while loop's execution, the recursive loop will continue forever and ever and ever, as there will be no way for it to exit. Every time that the while loop is accessed, it checks the statement's truth, and if you do not have the statement that removes its truth, then it will loop forever, and hence lock up and ruin your program. Let's write these in actual code and have a look at what they look like. So, I'm going to define a variable that just says int x is equal to 10. We're going to use this in a minute. I'm not going to have anything in void setup because I'm going to purely print everything to the console. I'm simply going to use the loop of void draw to control this program. Starting with an if loop. If x is equal to 10, so, if loops work like mini functions, but they have to exist within a predefined function. We can tell this due to the curly brackets. In the same way that void setup or void draw are defined and ended by the curly brackets, the computer knows that this if statement and its looping code are contained within these curly statements. So I can comment the end if. I can also if statement to check the value of x and output depending on it. So, reading down this, it initializes with an integer of x that equals 10. Void setup does nothing, and then looping void draw, we have a statement that says is the statement valid? If so, use the code. So, is x equal to 10? If it is, run this code. If it's not, run nothing. And you can see as 10 is equal to x, it loops through. But now, I'm going to add a new piece of code. Every time draw runs, I'm going to randomize the value of x. So I'm going to do x is equal to random 10 as void draw runs, it redefines the value of x. What I'm saying is make a random number between 0 and 10. Indexes start at 0, so we need one more digit than the value of the maximum we actually want. As in, it does 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for 11 digits versus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for 10 digits. I've also included this entire statement within brackets titled by an int function, which means that I only want the output of random to be a whole number. I'm also going to add a comment just to explain what that does. So now if I run it, we'll see that the statement appears in our console much less. But I want to also know what the value of 10 is when the if statement is not correct. So when our if statements run, we can branch the code off one way, but we can also branch off the second way. So we can include a loop for no and a loop for yes. To do this, instead of just ending our curly brackets, we add the else command, followed by another set. And what this is saying is that if x is equal to 10, then print this statement, otherwise print x. So what this will do is it will loop through and it will tell us if x is equal to exactly 10, otherwise it will print the value of 10 of x for us. So running it, we will see all the values that is being randomized, and then every time it's equal to 10, we get the x is 10 command. And that is the basic function of how an if statement works. And it's something that you will come across again and again through programming, checking whether your statements are valid or whether you want to execute a special piece of code. For example, in the game that we make, when our box is outside of the screen, we will use an if command to check whether it's here or not. Let's move on to the for command. I'm going to add a multi-line comment for my for statement just as I will use this code later. I'm also going to remove the random generation of x for now. For statements work very similar in the formatting to the if statement. If we look at the reference, you will see its syntax is for initialize, test, update, statement. And what that essentially means is that initialize what the limit of the for statement is, check to see whether it's real, and then do something to update the test to make sure that the for loop never sticks. This inbuilt update of the for controller means that they cannot crash or break your system. This is a nice example here. So what I'm going to do is I'm going to make a for I is equal to 0. So I is my initializer, and it's saying that the for loop is going to be controlled by the value of I. I'm going to do, well, I is less than x, I plus plus. So what does this say? This says, well, I is less than value of x, loop the for code. And we know the value of x is 10 as defined by up here. As a test for how this loop's working, I'm going to print the value of I within this command. I made the mistake of not defining what variable I is, so I'm going to include int I. To check its validity, I'm going to print the value of I in the for loop. And pushing run, we will see 0 to 9 pasted every single loop. Adding an ln will clarify this. So every single time our for loop is run, it's executing the code within it 10 times. We know this. So the for loop comes in, using the example we've used, does I equal x? If no, we use the code, whatever the for code is, and then we loop back, does I equal x now? Does I equal x? Does I equal x? Until finally, because of the I plus plus, which means whatever I is equal to, plus the value of 1, the for loop will self-execute and self-exit. What I'm going to do here, I'm going to save this sketch. Because I'm about to make a while statement, and I'm going to crash it on purpose to show you what the effect is. First thing I'm going to do is I'm going to bring up the while reference just to show you. So in the while loop, we can see that it runs the almost identical in the way that the for loop did, yet it lacks the self-updating within the parenthesis. So while something is equal something, execute the statements, exit. Using the example provided here for the lines, you can see that while I is less than 80, do something, but then they also have the additional line of I updating, which was present in the I plus plus statement of our for loop. Closing that. So using the same example as above, we're going to do while I is less than x, print I. And I'm also going to do I plus plus. So what this is saying is that we're making a new variable, a new integer I, just the same we did here. We're checking if I is less than x. If it is, we're executing the code. If it's not, we're just ignoring it. So if I run this, we will still see 0 to 10, printed into the console in the exact same way as before. However, if I now remove our incremental statement to falsify our test, what we'll see is 0 printed over and over and over again. While this may still seem like the program is functioning, we can tell this is not the output that we were wanting. My processing has now caused a memory overflow, as it has allocated too high a number to I, and as you can see, and probably hear, the fan on my laptop and the rainbow effect from processing has appeared. There's now no way for me to stop this executing, and there's no way for me to recover the work I've been doing unless I have a save file. The only way to quit is to force quit processing altogether. So now, processing is quit, I can reopen it. And that is an overview of looping statements within programming. Opening our reference, we can now add what we've learned about loop statements into here. To do this, I'm also going to bring back up the looping program that we wrote. Importantly, remember to add back in your falsifying statement if you didn't. And also, make sure you remember how important this statement is to falsify your while loop. Looking at the two side by side, I'm just going to take the code that we wrote. First thing I'm going to do is, instead of x, I'm going to use my integer 2 that we created previously. And I'm going to add a special comment line within my draw function to make sure I'm clear on what we're doing. Understanding variables, that was section 1. Loops, section 2. Again, you can format this however is going to be useful for you. I'm just doing this as this is how I remember. So first thing I'm going to do is I'm going to reference what we wrote over here. I'm going to do if integer 1 is equal to 10. And when I write an if statement like this, where I'm asking if an integer or a variable is equal to something, you'll note the double equals, as that means exactly equals to, versus other statements where we can have less than or equal to, or greater or equal to. Double equals is required in an if statement as it's a statement of fact versus just accessing or changing the variable. What you'll also notice is I've also just concatenated a print command. What that means is I've combined both a variable and a text print feature to make the combined statement that I want. So now instead of just reading integer 1 is not 10, it is. It will now read integer 1 is not 10, it is in fact plus the value of integer 1. So it will read, if you let me change this to a different value, you can see the actual value of it down here. This is just a neater way to error check your messages or get console commands from processing. I'm also going to change this to reference integer 2 versus integer 1. As earlier, in understanding variables, we change the value of integer 1 consistently. In the very first line of loops, I'm going to add my randomize integer 2 feature. So now in loops, I have integer 2 being randomly created, checking if it is equal to 10, if it is saying yes, if it's not, printing something else. Perfect. And in the same way, I'm going to include my for loop. So I'm just going to say for int I is less than integer 2, I plus plus. Now this is going to create an interesting dynamic for loop. Every time that this draw section runs, integer 2 is changed, which means that the length of this for loop is also changing every time the loop runs, every time the draw loop runs, as integer 2 might be 2, and the next time it might be 5, which means that this will loop once, and this will loop 4 times. So let's create a nice message based on that. This is the plus I plus nth loop of this for statement. So now when we play, it, what we'll see is our if calculation on integer 2 stating whether it is or is not equal to 10, and then we will see the printouts from the for statement, as this is a closed loop that happens before the relooping of draw. So this relates back to our spreadsheet or our flowchart from earlier, where this loop happens before the rest of the program can continue. No matter how many loops, this will always complete its looping before the rest of the program is dealt with. That's important to remember too, as when we deal with 10 or 100 loops here, that's fine, but if you accidentally tell a computer to loop for 1,000,000 or 100 million times, it's not going to happen instantaneously like we see here. And finally, we have our while loop. So I've defined a variable that we'll use to control our while loop, and while z, z is then integer 2, we're going to loop. While loop print z is currently equal to z. And then importantly, remember z++ to make sure that our while loop can iterate. I'm now going to play this, and what we should see is something that looks a bit like we'll receive an output from our if statement, all the outputs from our for statement, and then all the outputs from our while statement in one order. Just going to introduce an ln on the end of this for clarity. And now if I pause and expand the console, we will see our integer 2 if statement all of our for statement loops and then all of our while statement information. And that, added to a reference, is a great visual help on understanding of how loops work moving forward. So, let's add loops to our main program. The easiest way to do this is an extension on what we did last time where we drew a second box. But instead of us manually typing rectangle every time and then updating the variable, we can just change the variables and update rectangle on top of the last one. So, we can move it left, right, up, down, whatever we please. Before we introduce our loops, we need to make sure that our box actually moves, and then have some sort of condition to say why. What we're going to do is we're going to move this box right and down, and every time that the box is no longer visible on the screen, we're going to return it to its initial starting point. In this case, we'll make it 0, 0. To do that, we're going to use an if statement and check whether the box is actually inside our screen or not. First thing we're going to do is move our x and y position. Simply, we're going to create a new variable at the very top and call it int movement equal to 5. We're going to say xpos is equal to xpos plus movement. And we're going to do the exact same for y. So now, when we run this, we should see a box that moves down and to the right. Perfect. Uh-oh, we can also see hundreds of boxes. The reason that is happening is simply because we're not drawing a background. We know that processing works in a top-down fashion. So all we'd need to do before we redraw our box every time is tell processing to undraw the last box. To do that, we only need to introduce the background statement at the very first line in draw. This will create a completely black box every single time draw loops, erasing the previous box. Depending on the type of style and look you're going for, this can or cannot be added. Let's check whether our box is inside the screen. We need to check with an if statement if our x position is greater or equal to the width signified by the pink statement. This is an inbuilt variable that stands for the width of our screen. So if x position is greater or equal to the width, then something happens. If x position is greater or equal to the width, xpos equal to 0. So now, when I play it, what we should see is when x goes off the bottom, it should reappear at the top right. But it doesn't. Why is that? Let's use print to check what we're doing. So I'm going to print the x position inside the parenthesis, inside the for loop as well. So now I can see that our x position is being reset to 0 properly, but yet it's not showing. That must be because we've not reset our y position either. I'm going to copy and paste this and replace y position, x position with y position, and width with height. And as a quick top tip, if you push Command or Control T, processing will automatically format your programming code for you to neaten up your parenthesis and your curly bracket functions. Now when I run the code, every time it reaches the bottom right, it should reset to the top left. This is a great start. In the next lesson, we'll further this check bounds and make our box a bit bouncier. For now though, we'll save and leave it there.